Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
Hello guys, and welcome back to this video. This one is about text normalization. What we mean basically by text normalization is that we have text in different forms and we need it to have the same kind of form, so that, for example, we don't have multiple words in different shapes, and also we don't need to have words or text that is not of our interest inside our text. So in summary, we are going to go through how to reduce the text variation in our corpus, how to deal with the stop words, and how to do stemming and lemmatization. We're going to talk about them in the next video. We're going to apply them in NLTK library. So first of all, we need to import the dataset that we're going to work with, and this data will be the data from the first video, the last video, which is the news data that cover business and sport news. So let's start. First of all, let's see the article, of course, that we talked about. And let's take a look at the most common words in this article. Of course, you can see here that we have used the most common function, which is basically a function in the counter object. This function, what it basically does is show us what words in this text has the most occurrences. So you can see here that they, to, and in, and by, of course, one of the most common 5 words. And basically these words will be found in any other text. Like, for example, if you want to see if the text is about business or about sports, all of the time you will find these words in either business or sport text. So this is the definition of the stop words. The stop words are words that can be found many times in the text, but it has nothing to do with the topic of the text. It will be there regardless the kind of the text. So let's take a look at the most common words of the whole text. Here we use the join function. The join function basically is used to join multiple strings, a list of strings together. Like, for example, if we have this list with a word 1, for example, and word 2 and word 3, and we use the join function, for example, the join function basically takes a string, so this string will be here a comma, and we're going to call the join function. We're going to pass to it this list. So the output of this is going to be all the words or the text that is inside this text concatenated together and splitted by this string. We can of course change this one into space, for example, and in this case you'll have all the words splitted by a space. So this kind of function here, what it basically does, it join all the articles in the dataset and values here basically to convert it from a series into just a list of strings. And here we're going to see the most common words, the most common 10 words in all of our text. Let's take a look at this. And of course, they, to, in, of, and you can see that all of the words, almost all of the words, are just stop words. Nothing very special about them. They basically indicate nothing. So we need to get rid of these words so that we can reduce the amount of memory used, for example, by the bag of words model, because as you saw, the bag of words model assign a column for each word, and having this much of a words, like for example, they can be found 41,000 times. So all of these times are actually useless because we don't need the keyword. So here we can make a function, a shortcut function for getting the most common words. It will be taking a text and it has a limit, so we're going to apply the same concept but instead of the text that we have received in the function, and we're going to limit our output to the number given by the user. So let's take a look at the English stop words that can be found in scikit-learn, inside feature extraction module and stop words module. So we're going to import this, and to apply the stop word removal function, we apply the join function once more here, but here we're going to use an iterative list approach. The iterative list approach, basically, here is the step that we're going to make at each loop, at each iteration, and the iterations themselves are here. We are going to iterate inside the text.split, and every time we iterate, we're going to assign some variable here into the variable word. And if this word is not in the English stop words, we're going to apply it here. So that's how basically you make an iterative list. This is an iterative list. So all of this, we're going to generate a list of words. We're going to join them together, separated by space. So this function, what it basically does is going to take the string and going to return it once more, but without any stop words inside it. So let's take a look at the whole text, but with no stop words. And now we're going to see the most common words. And you can see here that now there is some useful word, but you can see here they, it is still here, despite it is a stop word and we have just did removing the stop words. So that is something called the text variation, where you have the same text but in different forms, like for example they with a capital T and they with a small t, and you might have also they but with all capital letters. And what we want to do here is we're going to remove all of the they or the stop words, either in capital letters or lower cases. So what we need to do now is to unify all the text that we have. So we're going to do a letter cases. So we have the same function here, the same join, where we join all the text together, but this time we're going to apply some function on the article column inside the dataset data frame, and the function will be a lambda function, which basically takes an input, which will be an instance of this article, and we're going to lower it, make it all in lower values, and of course values here because we need our output to be just list. So we're going to apply this one, and we now have a subset of our articles, but all of them are our lower cases, and we're now going to remove all the stop words from them. Then let's see how many words we're going to see here. Nothing, no stop words. So simply what I have done is that we have taken all the stop words and remove them from our text. And to make sure that all the stop words have been removed, whether in lower cases or upper cases, what we have done is that we made a reduction to all our words to make them into lowercase. Of course, this is not the best thing to do all the time, because sometimes when we work, like for example in a task where we search for the names, as we saw in the project in the later video, we will need to have the upper cases in our character because it identifies the names as we saw before. So making all your cases in lower cases is not a step to go all the way. It depends on the case that you want. You may have two versions of the text, where for one version you will have all the words in a small letter, and another version where you have the characters in their normal form. So so that you can extract the name from this one, for example, and for this one you are going to do the classification or the work that you are going to do. And something to mention here is that stop words here are the common normal English stop words. But for example, if you have some data about news, like here for example, you might see that said is a very common word. So said and new and world, these are words that are common in the news articles or tweets. So this also can be considered as stop words. So the stop words normally are the English stop words, but there might be also a domain specific stop words, which are the stop words that can be found in a large amount but inside a specific domain. We're going to deal about these in later video, but it's something important to point out. Okay, so another way to reduce the variation in the text is stemming. So stemming here, basically what is stemming is that we reduce the text. The way stemming works is basically it has some rules, like for example if the word ended by double ses, it will be reduced into double s. So here caresses will be cares, and if the word ends with ies, it will be transformed into an I, and we have some rules. So basically what stemming does is just applying some rules, and these kind of rules is the rules that were used in the Porter stemmer, and this is the link for the Porter stemmer itself, so you can take a look at this. So is that the best option that we have? Do you think that this is the best option? Of course not, because this kind of way, this rules to reduce some words will destroy some words. Let's say for example if a word ends with s, gas, gas will be reduced into ga, which is a word that means nothing. So stemming is not the best option to go each time. So we have lemmatization, and lemmatization works in a different way. It has the same objective as stemming, which basically reduce the word into its simplest form, but in lemmatization we reduce the word by going back into its origin. Like for example, studies will be reduced into study instead of study with just an I. You can see here that the stemming rules will replace the IES into an I, so the word will be study. But for example, studying might end up still be studying, and this might make some variation in words. But this is basically because lemmatization work by searching for the root of each word. So if it does not have a root for a word, for example, it didn't have this word before, it will just leave the word as it is. But if it did some action on a word, so that means basically is this word already we have a root for this word, so all the lemmatizing will be most probably right. So we can see here that cries will end up be cry, and cry will just stay cry. So this is lemmatization. So in the next video we're going to see how we're going to apply stemming and lemmatization using NLTK library. But for this video it's important to mention and recap quickly that we have dealt with text variation, how we can count the text. We can see the most common words, how we deal with stop words, how to remove them, and how to reduce the variation by applying lower cases in our text. And here we talked about stemming and lemmatization, and in the next video we're going to see how to apply them, and we're going to see the results on our text. So see you guys in the next one. Hello guys, and welcome back to this video. In this one we're going to install NLTK, and we're going to see how we can use the NLTK features such as the stemmer, lematizer, and all this kind of stuff. First of all, NLTK is a leading platform for building Python programs to work with the human language. It is widely used for natural language processing, and it has a large corpora and lexical resources such as WorldNet, which we are going to use later in this tutorial for lemmatizing. And basically, you cannot work in natural language processing field without knowing about NLTK. So first of all, we need to install it using pip install NLTK. So inside your terminal, we're going to initiate a command pip install NLTK. And of course, because I have it here already, it's going to tell me that it's already satisfied. And don't forget that you can apply this basically by having an exclamation mark and applying pip install NLTK. It will have the same result actually, because this is basically the same as applying it to your terminal. So after installing NLTK, you need to install some corpora. For example, some data that it doesn't come pre-installed with NLTK because it has a large size. So if you need any additional data in your NLTK, you have to start the NLTK and then start NLTK downloader. So after installing NLTK, you can initialize a Python terminal inside your terminal or even inside your notebook, and then we're going to import NLTK. So we're going to import NLTK. So if this line runs successfully, so that means that NLTK is already installed and everything's fine. So you can initialize the command nltk.download, which is basically going to initialize some GUI for you that you can install from it all the packages that have in NLTK. You can see here, this is the collections, these are the corpora, and these are the models, and these are all the packages. You can basically go here and install all the packages if you have the enough space and you're going to deal with NLTK for a large time. And instead you can just go through the corpora and install the corpora that you want. The corpora that we're going to need is WorldNet, so make sure you have WorldNet installed. And here we're going to install it, and of course it tells me that the package WorldNet is up to date because I already downloaded it. So that's how you install NLTK and its data. So you have all of these documented here in this notebook, so if you needed to go back to it anytime, you'll find it documented here. So let's get started first by import NLTK in our notebook and have some text here. The text here, please notice that the text here have wasn't, which has a comma here, and we're going to deal with tokenizers first. Let's see the normal tokenizer, the regex tokenizer that we have built before, which was surpassing the split function of the string, and you can see here that we have wasn't as a single word. In some cases, we need to interpret wasn't as two different words, was and not, because basically wasn't and was we will treat it differently, but we need to have was and not, because then we can deal with negation, and we know that this was is negated by the not. So let's take a look at the tokenizer of the NLTK. We have NLTK.would tokenize. So let's see the output of it, and you can see here that was and not are separated. Was and not are different tokens, and this can be very useful in some cases. So first, we have a word tokenizer that is better than the normal tokenizer, and of course you can see here that the empty set is not included in the words, so you only have tokens that are actual tokens and not empty space. Now into stemming. To apply stemming, there are multiple algorithms for stemming in NLTK and in general. The portrait stemmer is the stemmer that we have talked about in the previous tutorial, which basically applies some rules like removing some additional characters and reducing some different characters. So the rules for portrait stemmer can be found here. It is all documented in the NLTK because it's an open source library, so you can find all the code and you can go through it simply. So to use the portrait stemmer, we're going to import the portrait stemmer from nltk.stem, and we're going to initialize an object, just stemmer object. Here we have some words, some plural words, and we're going to see what the stemmer is going to apply to them. And you can see here, this is a different way of defining strings. When you have some variables and you need to include these variables inside the string, you just use an F in front of your string, and this is basically mean that this string is going to be a formatted string. And by having curly braces, we're going to define variables inside the string, and these variables are going to call the variables themselves here. So here we're going to have word, and this another curly braces, we have going to have the stemmer dot stem, which is the function that basically stem our string, and we're going to pass the words. So applying this cell, we're going to have each word and its corresponding stem. So you can see here that it indeed applied the rule, which basically was saying that if we have SES, we're going to reduce it into a single S, and we have IES, we reduce it into I, and all these kind of rules that we have talked. We have looked into these rules in the previous tutorial, and you can double check it here in this. So that's how you use the stemmer, the portrait stemmer. There is another stemmer that is called snowball stemmer. One of the advantages of a snowball stemmer over the portrait stemmer is that it supports different languages, and you can check the languages that the snowball stemmer supports using the snowball stemmer.languages, and you can see here it has Arabic, Danish, Swedish, English, French, German, Italian, all these kind of languages you can use. And you can see it has the portrait stemmer, which is basically an English stemmer, which is this stemmer. So let's initialize our stemmer. We're going to initialize it, and we need to pass the language that we're going to be using, and indeed it's going to be the English. So here we have the SN stemmer, so let's apply this cell, and let's take a look at the output of these cells. Basically, most of the time the snowball stemmer and the portrait stemmer have similar results, but in some cases the snowball stemmer is better. Most of the cases the snowball stemmer will be better. Let's take a look at this one. We have here the SN stemmer, and we're going to stem the generously word. Take a look at the stem. It's generous. What about the stemmer, the portrait stemmer? If we use the portrait stemmer, we're going to have it into a gener, because it's going to just remove all these text. So snowball stemmer and portrait stemmer are similar, but the snowball stemmer most of the time have better results. So it might be better to go into snowball stemmer most of the time. So into lemmatizing, and as we said in the previous tutorial, lemmatizing is about reducing the word into its root. To do so, you have to have like a tree bank or a knowledge bank that have all the words and its roots, and this is called the word net. So here we have word net lemmatizer in NLTK. That's why we installed and download the WordNet corpora from the NLTK download. So initialize the WordNet lemmatizer using a WordNet lemmatizer class, and let's take a look at the lemmatization of all the plurals words that we have defined here. And let's take a look at this. And flies have been reduced into fly, dies have been reduced into die, and this might be a little bit weird, but this is the root as lemmatizing seed. And you can see here, not all the cases are good, but not all the cases are good, but any word that it has already root for it, it will be reduced into a root. So in summary, what we have done in this tutorial, we have downloaded and installed NLTK, and we also know how to download NLTK data. We now know how to use the NLTK tokenizer and how it is better than the regex tokenizer. We now know how to deal with NLTK stemmers, how to stem words both in Porter stemmer and Snowball stemmer, and also in different languages because we have different languages in the Snowball stemmer. We know also how to use the word net limitizer from NLTK. So that's it for this video.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.